Hi, in this video, I will be showing you problem number 59 of chapter 5, section 4 from the practice exam. The velocity function in meters per second is given for a particle moving along a line. V of t, velocity, is 3t minus 7. T lies between 0 and 4, 0 and 4 included. A. Find the displacement. B. Find the distance traveled by the particle during the given time interval. So let's start up with the first part, which is finding the displacement. So displacement is integral of the velocity in the given time interval, which is in this case 0 to 4. Lower limit is 0, upper limit is 4. So it is integral 0 to 4, velocity which is 3t minus 7 given dt. So now let's integrate this. It is 3 integral of t, which is t square over 2 minus 7 times t between the limit 0 and 4. So it is 3 halves t square, which is 4 square, 16, minus 7 times 4 minus lower limit 3 halves 0 square minus 7 times 0, which is 0. So this would be on simplification, which is 24 minus 28. This is going to be negative 4 because it is displacement. It could be positive or negative. In this case, we get a negative value for the displacement. Then second part is finding the distance traveled. So the distance is integral 0 to 4 absolute value of the velocity. Integral of absolute value of the velocity, that would be the distance. So integral of the velocity is the distance. Integral of the absolute value of the velocity, in other words, integral of the speed would be the distance. Integral of the velocity is the displacement. So note the sign here. We are taking the absolute value of the velocity in order to find out the distance. So in this case, it's we are going to graph. We have to see, because it is absolute v of t, we have to see where the graph is positive or where the graph is negative. So absolute v of t can be defined as v of t itself whenever v of t is above the t-axis. And absolute v of t would be negative of v of t, opposite of v of t, whenever v of t is less than 0. Right? So v of t in this case is given to be 3t minus 7, which is a straight line with the y-intercept negative 7 and the slope. So it's kind of going to look like this. This value is going to be negative 7. It's going to cross the t-axis at 7 over 3. If you set this to 0 and solve for t, it is going to be 7 over 3. So it crosses the t-axis at 7 over 3. So for values smaller than 7 over 3, the graph is below the t-axis. For the values of t more than 7 over 3, it is above the t-axis, or it is positive. So we are going to divide this integral up to 7 over 3 and then up to 7 over 3, then 7 over 3 to 4, because the entire distance need to be evaluated only between 0 and 4. So in the part 0 to 7 over 3, the graph is below the t-axis, or v of t is negative. So it is 0 to 7 over 3. As the graph is negative in this one, we are going to take that to be 7 minus 3t. We are going to switch the sign, and then between 7 over 3 and 4, the graph is positive, so we are going to keep the function as is. Now you integrate. So 7, integral of 7 is 7t minus 3 t square over 2 between the limit 0 and 7 over 3 plus 3 t square over 2 minus 7t between the limit 7 over 3 and 4. Here there is a little bit of computation involved, but you plug in the upper limit 7 over 3 and then plug in the lower limit 0 for the first part. Then for the second part you plug in the upper limit 4 and the lower limit 7 over 3. Then if you take the LCD and simplify, you're going to get 37 over 3. So if you want to look at the computation that I have done, you go ahead and check it. Hope this video helps.